Hi, I want to go over some things you need to know for your next spreadsheet assignment. And I have worked up an example that is going to use a number of functions to include the Excel percentile function, a different use of the COUNTIF function, and then I'll also be demonstrating the logical function OR and the logical function AND in conjunction with the if function that you already know about. So let me explain how this spreadsheet works, the problem being solved, and then we'll look at how these functions are part of the solution. So I'm pretending that I've got some data that's been given to me concerning students that are interested in attending Anderson University, and I may be interested in calling some of them, and my criteria for calling them would be if they satisfy either of two conditions. One condition is they have a overall math SAT score that calculates at or above the 70th percentile among all the students in the list. So I'm going to use an Excel function, the percentile function, and it's going to consider all the data in this range and calculate a value that represents the value at which 70% of the students in this range, or 70% of the scores in this range, fall beneath that point. So that becomes my threshold for identifying students that have a strong math background. And then I'm also interested in the overall SAT score, the combined math and verbal score. And if it's 1100 or above, then I would be interested in calling those people as well. So a person could have a high math score and a low overall score, and I would call them, or they could have a low math score and a high overall score, and I'd call them. Okay, so that's my criteria. I'm going to have to do a calculation in order to identify those people. I'll hold off on looking at the COUNTIF function, but let's take a look at why it's telling me to call, and why the number of people that it wants me to call from column E differs from the number of people it wants me to call from column F. The reason for that is I'm using a logical function OR in making a decision, so I'm putting that OR function inside of an if function. I'm using that OR function to satisfy the Boolean expression part of the if function. And so I use an OR in column E, and then I do the same thing, except in column F I use an AND function. So, as you look through the results, it appears that AND is more restrictive than OR, and that is the case. So when would I use AND and when would I use OR? Well, we'll find out that OR is the function to use under these circumstances, but in general, a way to understand this is to consult what are called truth tables. And when I set truth tables up, I look at two expressions, and then based upon the way they evaluate individually, so these would be Boolean expressions, each one would be a separate Boolean expression, and each expression will evaluate either true or false, and then I look at how they evaluate together, and that determines the overall outcome. So for instance, one of my expressions might be to look at the value stored in B9, and that doesn't exactly correspond with this, so don't get too concerned about that cell address. But I could look at a value that's in a cell and then compare it to a calculated value and see whether or not it's greater than or equal, for instance. I could in another expression look at a different cell value and compare it to a constant. Okay, so I'm doing that kind of thing in this example. So this would be expression 1. In and of itself, this is going to evaluate either true or false. In and of itself, this one is going to evaluate either true or false. So the individual outcomes, true or false, are shown in the first two columns of the truth table, and then the overall outcome is shown in the third column. And it's this overall outcome value that's going to influence whether or not the if function takes the true path or the false path. So the overall outcome is going to drive the overall function of the if function. So we do the same kind of thing with OR. Individually, these functions are very simple. Okay, you simply invoke the function by its name the way you would any other function, and in both cases they have an argument list that consists of two arguments, and we just enter in the expression to be evaluated. So that argument's going to evaluate either true or false. That argument's going to evaluate either true or false. And if it's and, I consult the truth table. If the expression 1 evaluates true and expression 2 evaluates true, then the overall outcome is true, and that would influence the if function to take the true path. On the other hand, if I'm working with and, if either expression 1 or expression 2 evaluates false, then the overall outcome is false, and that would influence the if function to take the false path and display nothing in this case. Now OR works a bit differently, so it's going to look at expression 1 and expression 2, and if either one of them evaluate true, then the overall outcome is going to be true. So it's going to be much easier to get to this true path if I use OR than it would be if I use AND. So as we look at the data, if I'm using OR in column E, okay, which I am, okay, you can see that, that means that it only takes an 1100 down this column, or it only takes 572 down this column to influence me to call. So in this case, I've got somebody that does not meet the 70th percentile threshold, but their overall score is 1150. I would call them. Here's someone whose whose math SAT score is 600, so they meet this threshold, and their overall score is above 1100, and they would, if I am ORing, they would be true. Expression 1 would evaluate true. They have a math SAT score that's greater than or equal to the calculated percentile, so that evaluates true. The second condition, that they have a overall SAT score above 1100, is also true. So I would have true, true, and the overall outcome would be true, and I would expect to call them. Let's try somebody else that fails. Okay, so we've got Buzz up here, and he has a math SAT score that's below the threshold. So his score is not greater than or equal to the calculated percentile, so he evaluates false for expression 1, and he also has a overall SAT score that's less than 1100, so second expression, individual score greater than or equal to 1100 is false. He would reside on this false path, and the overall outcome would be false, and therefore the if function would take the false path and not call. So that's the way OR works. If we look at the way AND works, same idea. We use the AND function in the first argument of the if function. Okay, so again, first argument of the if function is a Boolean expression. That AND function will evaluate either true or false. And so under these circumstances, it's saying call. Why is that? Well, the first part of the expression is whether or not B18 is greater than or equal to the calculated percentile, whether it's greater than or equal to 572. So the value in B18, 600, is greater than or equal to 572. That evaluates true. The second part of the function is evaluating the expression D18, I want to mess around and lose something here. D18, which would be 1280, is that greater than or equal to 1100? Yes, it is. So the second one evaluates true, and so we would have true ANDed with true. True ANDed with true gives me a true outcome. If we look at one of these others, okay, so let's take, for instance, this one does not say call. Why is that? The first expression, where we compare the math SAT to the calculated percentile, 600 is greater than or equal to 572, so that evaluates true. And then we look at the total SAT score, and when we evaluate the second expression, which would be 10 greater than 1100, that evaluates false. So we would have a true ANDed with a false, which gives me an overall false outcome, and therefore the if evaluates false and takes the path where it just displays that empty string. Alright, so what I'm doing is I'm evaluating two expressions concurrently, and that drives the outcome of the if function. Now, the last thing I wanted to show you here is the use of COUNTIF. Okay, so you'll notice that in this cell there's a return value of 3, and it's supposed to be telling me the number of people at or above the 70th percentile, which has been calculated to be 572. And if I look at this list that corresponds with the range of the first argument of the COUNTIF, if I look in that range, okay, there are 1, 2, 3 scores that are greater than or equal to 572. So when I look at the way the COUNTIF function is written, it is written in a familiar way where the first argument is the range to check the patterns from, but the pattern is written differently because instead of choosing a value of 572, which would have checked for equality and returned a value of 0, it's by putting that greater than sign in, it evaluates each of these values numerically and will return any that are greater than 572. So even though I have that wrapped up as a string literal, because I'm using the greater than as part of the pattern, it's going to evaluate these things and check the numeric values to see whether or not they are greater than. And so it's only going to return a count of those with a value greater than 572, which again turns out to be 1, 2, 3. Okay, so that should do it for this spreadsheet. And again, if you have any questions about the way these functions work, you can always go to the help files. Okay, so Excel has excellent help files. Go through that, find the function, read about it, drill down by clicking on this hyperlink, or you can just simply do a Google search for Excel and then name the function, and you'll find that there are many links that explain how they work.